I'm a smiley man.
Hey guys, my name is Kovidani. I'm a certified Solidworks professional as well as an expert in 3D printing. Today I'm going to show you how to make awesome cosplay replica props like this axe from World of Warcraft. I'm going to show you how you can make an axe inspired by this one in Solidworks and then 3D print it to bring it to life. Let's get going. So first thing to do is to open up Solidworks, and we're going to basically create a new part. A lot of this I'm going to speed up because a lot of the functions that I do use here are basic functions. If you have a basic knowledge of SolidWorks, you should be able to get through these kind of shapes easily. When it comes to merging all of the parts, all of the bodies together, it's important to have a single body in SolidWorks for 3D printing. If not, where bodies merge, it creates a negative space where nothing gets printed. So if these bodies stay how they are now, in between them, there's going to be no material holding it together, pretty much, basically. So it is important to make sure that you merge every single body into one body for the print.
Nightmares creep while you and me repeat. This bittersweet heat is suffocating. I'm waiting and always hesitating. Kryptonite desires set my heart afire. Set my heart afire. Yeah. just can't stay still. Don't stop that thrill.
Once the model is complete and you're happy with it, first things first is save it as an STL as a whole. Basically what we're going to do now is import it into a slicing software. Slicing software is what turns your 3D model into a format that the printer can understand. It is basically a CNC code that tells where the head should move on the various different axes. Now that you've saved your STL, it's time to take it into the slicing software of your choice. All you need to do is just import it into your slicing software, and immediately you'll notice a problem. It is way too big for your print bed. This is okay. There are features within slicing softwares to fix this, such as the scale feature, which allows you to make it any which size you want. As you can see now, it's yellow. You can now essentially print this. So if we go into the layers, have a look at it quickly. As you can see, what is red and green is the actual model. What is blue underneath there is the support material. Now you can go ahead and print this. The only problem is one side's going to look super awesome, the other side's going to look super meh at best, because support material does damage the surface area. So ideally you want to get away with as little support as possible, which I'm going to show you how you can do now. So we're going to go back into Solidworks. We're going to cut this up into smaller, more manageable pieces, which will allow us to orientate them into different directions and print them support free. But you'll see how that all works out in a mo. So we head back to Solidworks, and what we're now going to do is scale it and cut it up so that it prints in pieces, which will make the print a lot more friendly, orientate them so that they fairly support free. Now with something like this is that you can scale this model to any scale that you want, and you can cut it up to any size that you want, depending on what you want, depending on the size of the model you want, by using all of these basic techniques that I'm about to show you. First thing I'm going to be doing is, once you've scaled the model, you're going to be splitting it up into various parts. As you can see, I split it here into 4 pieces. By creating a surface, you're able to split it without losing any of the bodies as you would with a normal cut. Best to hide the surfaces so that they're out of the way. The feature I'm using now is the delete body feature. The idea of this is so that you can isolate each individual body, save them as individual files. Save it as the file, go back into the feature, change the body that you want to keep, and then save that as the second file. I find this, especially once you've split a model, the easiest way to isolate your individual files. What I'm doing here is, this is a huge overhang that will generate a lot of support in front of the pattern that I've created. What I'm doing is I'm creating a 45-degree angle on that overhang. With the way 3D printing works, any angle that is more than 45 degrees to the print bed will not build support underneath it. Anything less than 45 degrees will build support. So ideally what I'm doing now is making sure that it is a support-free design. Now the details that are made there, no support will be shown there, purely because they're not deep enough. Any depth in an emboss or a deboss that is more than 0.5 millimeters will add support material in that emboss or deboss. So now that you have sliced up your file, let's import them one by one into the slicing software. I do this one by one purely because I prefer it this way. The machine that I'm using handles a lot better if it is done one by one. But let me show you an example of how orientation can affect your model. So I'm going to copy this quickly. Come on. Oops. There it is. So now we've got two of the exact same part. The one I'm going to orientate in a support-free manner, which means it's going to print completely, well, mostly support-free. I think it can get away with that. I think there might be some over there. And some over there. Whoops. My phone dropped. It's fine. Safe. So now that you've got the two pieces, let's have a look how it's going to look in the layers. As you can see, the one on the left is completely red. It's going to be completely support free, well, mostly support free, except for a few little places which will be easy to clean off, such as over there. But as you can see, the other one is completely packed with support. This could almost double your print time, having support like this. So it is always good practice to try and make it as support free as possible. So let's go ahead. What we'll do now is we'll import each one individually, one at a time, save their G-code, and then we can get to printing. So now that all the pieces are sliced and on the SD card, it's time to print this bad boy. Alright guys, now that everything is printed, it's time to put it all together. So I'm just going to show you how to clean basic 3D printer parts, how to fix errors such as this part which failed part way, how you can correct that without having to reprint the entire part. And then I'm just going to paint it, giving some tips and tricks on how to paint and assemble your 3D printed replica. So let's go. Simple tools you need for cleaning off support is a pair of pliers or cutters and a knife. So this part has some very basic support on it. Because of the way it was designed to be as support free as possible, there isn't a lot of support. So I mean, this stuff literally just peels off and breaks off. Use a pair of pliers just to pull out support in some areas that are difficult to reach. Use a knife to just clean up some extra little bits that are hanging about. So with this part that failed, basically what had happened was the printer was bumped and the part was misaligned, which allowed the head to knock it off, and it printed what was called spaghetti, which is basically where the printer's just printing around and the material's coming around and it looks like a big bowl of spaghetti. So to fix a problem like this was a 4.5 hour print. I think it had 20 minutes left to go to print the top here. So instead of printing the 4.5 hour print again, the best way to resolve an issue like this is to actually measure how far it printed. Best to use a vernier caliper to get an as accurate measurement as possible. Then go into Solidworks and open this part and then cut where that piece printed, where that piece stopped printing, so that you have this piece. And then all you have to do is print that piece, the two parts align. Obviously there's going to be a bit of a split line over here, but with a bit of filler, bit of extra care when it comes to the post-processing, you can get rid of that. But that's just a quick fix-it tip on how to finish a print without having to reprint the entire thing. Obviously if this was a structural integral part, it would be better to print the entire thing again. With gluing these parts, super glue is adequate enough. You can use some araldite or some epoxy resin, but for something small like this, bit of cyanoacrylate super glue will be fine. And then I've got an accelerator just to speed up the drying process. So let's get gluing. There we go. My suggestion is after gluing, leave this for about 30 minutes just to make sure that all the glue is dry, everything's set in its positions, before actually starting to paint. Now that it's all dried, we can start painting it. I'm just going to use some basic acrylic paints. You can use almost any paints on these models here. So I've laid out some newspaper, some paper, so that I don't mess on you. With acrylic paints, they are water based, so if you do mess, you can just wash it off. So plan is to do kind of these in a darker brown. This in kind of like a lighter woody brown. The rest of it has like a metal grey look. There is the axe, very lightly painted and dry brush, very simple techniques to use, takes no time at all really, and yeah, you use the layers to kind of help your effect that you're trying to achieve sometimes. I'm pretty happy with this, and this is ready for me to ship. So this is the result at the end of all this work. A prop inspired by the upcoming movie Warcraft. Some simple techniques shown in Solidworks. You can scale this up to any size that you want, changing your cuts into different areas, allowing you to make this as big as you want. I hope you guys enjoyed this. Hope you guys learned a lot from this. If you have any questions for me, leave them down in the comments below, and I'll be able to help you out as much as I can. See you guys in the next one.